All right, hello everybody, and this is video 3.4C, and it's going to be inequalities with multiplication and division. The last video we did inequalities with addition and subtraction, so now we're just going to add a little bit more to that. If we take a look at our I can statement, it does say I can solve inequalities with multiplication and division by using the same method as solving equations and flipping the sign when necessary. Okay, so what we're going to be when we're solving inequalities with multiplication and division, it is the exact same process as solving equations, just like before with addition and subtraction. But with multiplication and division, there is one special rule with flipping the sign. Okay, we'll get to that special rule after this example. Okay, because I want us to look at a quick, easy example, and then we'll get to the one that's a little bit different. So I have 5 times x is greater than 65. Okay, so again, my goal, just like with equations, is to isolate the variable, get it by itself. So what I need to do is I need to cancel out this 5 somehow. And what I'm going to do is I'm going to do the inverse operation of multiplication. Well, to cancel out multiplication, we do division. So I would divide by 5, because 5 divided by 5 cancels each other out. That's just 1, and 1x is just x. And I'll divide my right side by 5. I'm left with, bring down my x is greater than 65 divided by 5. Let's just work that out real quick to make sure we get it right. I don't want to rely on my mental math. 5 goes into 6 one time. Let's subtract 5. I'm left with 1. Bring down my 5. 5 goes into 15 3 times, and I won't have a remainder. Okay, so 65 divided by 5 is 13. So x is greater than 13. There's my solution. Okay. What I need to do now is just graph it real quick. So I'll put 13 on my number line. To the left of 13 is 12. To the right is 14. All right. X is greater than 13. So because it's greater than 13, I'm going to use an open circle. Okay. Because it's not greater than or equal to 13. It's just greater than. So that means 13 is not a part of the solution. And it's greater than, so that means I'm going to shade to the right. Okay, so x is greater than 13. The graph would look something like this. Okay, simple inequality with using multiplication and division. It does get a little bit more complicated, but not much, because there is one special rule. We have to flip the inequality sign when multiplying or dividing by a negative number. So if we take a look at this, I now have -4 times t is less than or equal to 24. Now I still want to get t by itself. I still want to isolate my variable. So to do that, to cancel out multiplication, I'm going to use division. So I'm going to divide by -4, because negative divided by a negative is a positive. So I need to divide both sides by a -4. -4 divided by -4 cancels each other out. I'm left with t. And now I need to flip my inequality sign. So before t was less than or equal to, now it's going to be greater than or equal to. 24 divided by -4 is -6. So my solution is with a flipped sign. T is greater than or equal to -6. So let's go ahead and graph that inequality. Here's -6. On the left of my number line would be -7. On the right would be -5. Okay. I have greater than or equal to, so I'm going to use a closed circle because -6 is included. And if it's greater than, we're going to shade to the right of our number line because all these solutions are greater than or equal to -6. Now let's look to see why we flip that sign. If I were to take any number from my solution over here, so I would have a -4 here, this would be -3, and then all the way over here somewhere, I'm going to have a 0. Let's plug in 0 because that's part of my solution. Let's plug in 0 and see if that makes my inequality true. Okay, so if I have -4 times 0 is less than or equal to 24, -4 times 0, that's just 0. Is 0 less than or equal to 24? Yes, it is. That works. Now let's plug in 0 to this inequality as well. When I flip my sign, I'll have 0 is greater than or equal to -6. Is this true? Yes, it is. Okay. It satisfies both inequalities. So that's why we flip our sign. If we didn't, the solution set would be backwards. Okay. So let's take a look at 2 more examples and then we'll be all done. Okay, oh, well, somehow my division sign got deleted here. Let's just fill this in. There we go. So let's solve this inequality. I have m divided by -2 is greater than or equal to -8. So we need to isolate the variable. And because this is m divided by -2, I need to do the opposite of division, which is multiplication. And I'm going to multiply by -2. And whenever I do the left side, I have to do to the right side. So I'm going to multiply by -2. This is like having a -2 over 1. So these cancel out right here. If you cross-reduce these fractions, they cancel out. So I'm left with just m. But now, because I multiplied by a negative number, I need to flip my inequality sign. So before it was greater than or equal to, now it's less than or equal to. -8 times -2 is positive 16. So my solution is m is less than or equal to 16. So now let's graph that. Here's 16. I'll put 15 all the way over here, and we'll put 17 all the way over here. First thing I need to determine is whether I use an open or closed circle. And because it's less than or equal to, I get to use a closed circle because of that or equal to part. And m is less than or equal to 16, so I'm going to shade this way. So here's the actual inequality, and then here's the graph for the solution. One more example. Let's solve this inequality and then graph our solution. I have y divided by -3.5 is less than or equal to -7. Because there's a decimal in the denominator, it does not change the process of how to solve this problem. So because I have y divided by -3.5, what I need to do is I need to multiply by -3.5. And whenever I do to the left side, I have to do to the right side. Multiply by -3.5. These cancel out. That's why we multiplied. Our goal is to get y by itself, and these cancel each other out. That's why we did it. Bring my y down. I multiplied by a negative number. So because I multiplied by a negative number, I need to flip my sign. Okay? And -7 times 3.5, well, I don't know what that is. So let's work that out real quick. 3.5 times 7. 7 times 5 is 35. Bring up my 3. 7 times 3 is 21 plus 3 is 24. And I have one number after the decimal, so I need to move my decimal over once. So y is greater than or equal to, this is going to be a positive 24.5. The reason why it's positive, a negative times a negative is positive. Now to graph it, let's go here. We'll put 24 here. Let's put 25 here. Halfway between 24 and 25 would be 24.5. So I'm going to use a closed circle on 24.5 because it's greater than or equal to. And it's greater than, so we're going to shade to the right. So this is the solution, and here is my graph for the solution. And that's it for solving inequalities with multiplication and division. Let's just remember that when we multiply or divide by a negative number, we have to flip our sign so the inequality remains true. And that's it, you guys. I hope this video helped, and I hope everybody has a fantastic day. Thank you.